So, we are done with this, so we'll move to further examples on the image of an element, okay, without wasting much of the time. So, I have this other example here. So, still on the image of an element, if G is such that X binds with N, where X equals 2, 3, 4, and 5, and their binding rule, binding rule or formula is X then X plus 4. What is the image of 3 and 5? That is the question. So, without wasting much of the time, we will definitely see how we can deal with this kind of question. Don't forget the topic is still image of an element. If G, that means the name of the application is G, such that X binds with N, where X equals 2, 3, 4, and 5. So it means they have given us the value of X. Ordinarily, we can now say G of X in this case equals what? 1. Mathematically, okay? But if it is, for example, F such that X binds with N, it will still be F of X equals 1. But because the name of the application is G, that is why we have G of X here. I'm just trying to make sure you really understand what it is. Now, in this case, they have given us all the values of X, okay? The corresponding value, this means now that this X, according to this formula, everything that has been given for the value of X, 2, 3, 4, and 5, will be under X, and this other part is the codomain. So let's write it again. That is, I have to divide this into 2. Let me use a zigzag line. Now, X binds with X plus 4. So it means this part is the domain and this part is the codomain. You can see what we are trying to do. This part is the domain, part of the application, and this part is the codomain. Now, it means for X, we have what? 2, 3, 4, and 5. I hope you can all see from this part of the board. Okay? So it means for X, that is what we have. And this means this is the codomain. Then to get this other part, the formula says you will have the value of X, or you have 4 to the value of X. So the value of X here is 2, 3, 4, and 5. So all we need to do is to add plus 4 to everything. So 4 plus 2 will give you 6, 4 plus 3 will give you 7, 4 plus 4 will give you 8, and 4 plus 5 will give you 9. So it means when X is 2, it's going to bind with 6, this one will bind with 7, this one will bind with 8, and this one will bind with 9. So that is the solution. Easily from here, you can get the image. According to the question, it says, what is the image of 3 and 5? So the image of 3 here is what? image of 3 and 5. What will be the image of 3 here? It will be 7, and the image of 5 will be 9. So that is the final answer. As simple as A, B, C. They can have you, ask you a lot of questions under the same question. Like, for example, you can be asked to write out the range of this application. Range, when range is equals to the, they can ask you if this is an onto application. You all know when the range is equals to the code domain, that is when you have onto. They can ask you if this is 1-to-1. This is also 1-to-1 because each element from the domain binds with just one in the code domain. It's simple and direct. One element to one here, one element to one, not one element going to two elements. So that is what makes it 1-to-1. And if you check very well, everything in the code domain is arrowed. So that shows that this is an example of onto and 1-to-1 application. Now, we will move to the next thing for today. That is what we call correspondence, the correspondence application. Correspondence simply means when you have 1-to-1 and onto, all in one application. Just like we have here, this is 1-to-1 and this is onto. If you are asked if this is correspondence application or if this is correspondence function, definitely it is. Why? Because the two applications that are required to make it correspondence are there in this very example. It is 1-to-1, it is also onto. So right now let's have the short notes on what correspondence is. When we have onto and 1-to-1 in the same application, at the same time, then the relation of function like application is called correspondence. Correspondence. For example, if x equals 1, 2, 3, and 4, and y equals 1, 4, 9, and 16, if x binds with y, where f of x equals x squared, the application is 1-to-1 and also onto. Now, we need to prove if this is an example of correspondence function or application. Now, let's go back to the beginning. It says, when we have onto and 1-to-1 in the same application at the same time, then the relation is called correspondence. If x, for example, don't forget, always bear this in mind or put it at the back of your mind, when we have 1-to-1 and onto in the same application, that is when we have correspondence. If x equals 1, 2, 3, and 4, and y equals 1, 4, 9, and 16, if x binds with y, where f of x, I told you when you have f of x, it means y equals x squared. The application is 1-to-1 and also onto. Okay? So it means in mathematics, when you have a square, or when x is raised to power 2, or any variable given here is raised to power 2, the kind of application or the kind of connection we have between the domain and the codomain will be correspondence. Now, I want somebody to take a screenshot of this so that we can have a copy of it. Okay? Don't forget, we're still dealing with the image of an element, and after this class we'll go to something very important, which will be the circle geometry or theorems. So according to the question we have, where we just need a little proof, they said already f of x is equals to x squared, and the value of x is given already. So let's see if it's going to correspond to what we have for y. Don't forget, y means f of x, okay, and that is why why they are writing this y here. So if f of x equals x squared, it means for every value of x there must be a value for y. So if f of x, for example, the first element of value here is 1, f of 1 will be equals to 1 multiplied by 1. That is 1 squared, and square that will be what? 1. And for f of 2, we have the square of it will be 2 in 2 places, 2 times 2, which will be equals to 2 squared. That will be 4. Then f of 3, that will be 3 multiplied by 3, 3 in 2 places, that will be 9. Then f of 4 will be 4 in 2 places, that will give you 16. Now, if you check very well, you can see it corresponds with what we have for y. So it means for every value of x, there is another corresponding value for y. And if you check very well, it is equal to what has been given to us already. So now, if we are to draw this using, I'm using the diagram just to show if it is correspondence or not, which means it has to be 1-to-1 at the same time onto. That will be 1, 2, 3, and 4. When it was 1, it was 1 also. 2, it was 4. 3, it was 9, and 4, it was 16. So let's connect them together. So you can see this is 1-to-1. One element is going from, don't forget, we are talking about x and y domain according to the question, because it goes from x to y. And 1 goes to 1, 2 goes to 4, 3 goes to 9, 4 goes to 16. That makes it 1-to-1, because one element from domain x is going to be one element in codomain y. And of course, if we are to check if this is onto, it is onto as well. Why? Because everything in the codomain is arrowed, and when range is equals to codomain, because range are all the elements that are arrowed in the codomain, and all are arrowed already, and of course all are in the codomain. So range is equals to codomain. So we have 1-to-1 here. And at the same time, we have onto application. So in that case, you can say this is what? Correspondence. Application. So that is just the proof to what we have here. So there will be an activity or work to do from home, okay? So that work to do is from your textbook, exercise 2-6, page 31. That is maths for grade. Work to do or activity. math for grade 8. Page 31. Exercise 2-6. If x equals -1, 0, 1, and 2, then y equals 1, 2, and 5. F such that x binds with y, where f of x equals x squared plus 1. These are the questions under it. This is the formula of the rule that guides it. It says write the application in form of ordered pairs. Remember, I taught you that in the very first class we had during this very online teaching ordered pair. B part says show the type of application of function. Show the type of application of function. So it means after you must have worked it out, you have to show all the applications or the types of applications you are able to see in the diagram. So if it is onto, if it is one-to-one, if it is correspondence, you give us what it is and you give me the reason at the same time, because without the reason you will not get your full mark. So it means you have to work it out with this formula that has been given. Don't forget now, they gave you a value for y already, and y equals to f of x. I'm just giving you a platform, to find a way to go about this. So it means f of x binds, f such that x binds with y. So where we have your x now, -1, 0, 1, 2, okay, will be used here. So whatever value you get for -1, you write it at the front of -1. For 0, you do the same, just like the way I did this, okay? The exact way I did this is the same way you're going to go about this. So now, get the values that give you the same result of what you have in y, which is the codomain 1, 2, 5. So anyone that is able to give you answer that's got to be 1, 2, or 5, you connect them together and you check and give us reasons if it is one-to-one, if it is onto, or if it is correspondence. So without wasting much of the time, we have come to the end of the class. Don't forget to go to our YouTube channel, that is Tendercare Motorstolic. It is written together. That is where you'll be able to see a copy or to check this very teaching very well. If you are not able to understand fully, you can, go to the YouTube page for Tendercare Motorstolic. You can repeat at the same time. You can take it back to be able to grab everything that has got to do with the class. And it is very important that you do all this activity we give to you in the class or what to do for this very online teaching, because it will help you to go a long way in your studies. So the next time we'll be meeting, I wish you the best of luck and stay safe. At the same time, don't forget to stay at home. Bye.